So we got our loop here. So what's going to happen, you guys, when we turn this on, well, let's go ahead and just turn it on. Watch the reaction. All right, so we're getting, what do you guys see? So again, you have to come up with your observations here. What are we seeing here? Bubbles.
Hydrogen's being created and
The H2O is being...
So here people are saying that we're seeing hydrogen oxygen gas being formed. So what's happening to my water, the overall reaction?
going to hydrogen gas.
Plus,
H2 plus.
We got to balance it, right? So if we're balancing it, we're getting twice the amount of hydrogen as we are oxygen, right? Does everyone see that? So looking at that, can you guys see that up here? That we're getting one side is twice as busy as the other side.
Left is hydrogen.
Okay? Does everyone see that? So that's how we can figure out which side is the hydrogen and which side is the oxygen. All right? Yeah, so if people can't see, so make sure people get, I'll leave this up here for a while. But we're also getting this color change is happening. So like I told you guys, the color change on this side, it all started out blue. This has got bromthionyl blue indicator. So the indicator on the one side has gone to an acidic pH, this green or this yellow color. The basic side has got our blue color. So we're trying to figure out what the two reactions are. Because when you guys do your Petri dish 9-volt battery, you don't see gases on both sides, right? You guys saw iodine getting, what was happening to the iodine?
It was being oxidized.
Right? Actually 2 electrons, I guess, right? We're not seeing that here. We're not seeing that. We're seeing gases off both electrodes. So what this one, so when you guys did this, you had sodium iodide in water, right? And we got this. Did you figure out what the other reaction was here? So if this is being oxidized, what was being reduced? How do you know the sodium wasn't being reduced? Well, you can see it, right?
because it's basic.
Alright, so here you guys saw is basic, you're getting this. That's not right, is it? Yeah, okay. Does that look good?
Yeah.
Alright, so this is what we got with sodium and water. But now, what I've given you guys is sodium sulfate. And when we put sodium sulfate, what are the two reactions? What are we getting here? We're still getting the water being, what, reduced or oxidized? What's happening to the water again?
No, it's being reduced.
So it's being reduced. So again, think of it, this, you guys, the H plus, the HOH, this H plus is turning to 0 charge, right? It's getting reduced. The OH minus is left behind. That's why we're getting the basic side. So now when we use sodium sulfate, so this is all with the sodium iodide. With the sodium sulfate, we're still getting the water being reduced. Right?
Wait.
So what's happening on the other reaction? Oh, Mark, yes.
Wait, what did the sodium sulfate have to do with anything?
What's that?
Why are we talking about sodium sulfate?
Because that's what's in here.
Oh.
That's what's in this. When I make this for you guys, and that's gonna be one of my questions. Why do I even have to have sodium sulfate? So let's think about all these things. What's my other reaction? We have water being reduced. What else is happening?
Doesn't that indicate if it's like an acid or a base?
That's what the bromthionyl blue does. Yeah, we got bromthionyl blue. Yeah, no?
Is it to cancel the charges?
Not exactly. Not exactly. Because they're all in the same container here, so that won't matter. That's all one big glass thing. Right? There's no separate compartments. What's my other, well, let's start with, what's my other reaction? What do you guys think?
SO42 minus being oxidized.
So, SO42 minus, I'll say, is not being oxidized.
It's not being oxidized.
Well, I gave you guys overall reactions. What's the overall reaction? What are we missing?
To the O2.
O2. So where's the O2 coming? It's not coming from the sulfate.
From the H2O.
So water is being reduced here,
So you could,
but on the other side, water is also being oxidized. Water can be oxidized and reduced, right? But instead of, so when water gets oxidized, what's going to be oxidized? The H plus or the O minus 2? The O minus 2, right? This is going to get oxidized. What's going to turn into?
O2
And if oxygen all got turned away into gas, what's
or H
left?
plus.
The H plus ions. That's why we're getting the acidic side here. So we're getting some acid. That's why we have the acidic side and the basic side. We've got the clear or yellow. It's got a yellowish tint to it, but it's hard to tell with that orange. And we've got the purple over here. All right? So, oh yeah, question.
Wait, so in here is water and then the...
Water and sodium sulfate.
shouldn't What was the point of the sodium sulfate?
So what's the point of the sodium? So what if I just put pure water in here? That's kind of the key to it.
Then
What would happen if we put pure water in
Oh,
there?
there's no ion.
No ions. So what would happen?
nothing.
No flow of electrons. Would anything happen?
No.
No. Nothing would happen at all. So if you put pure water in there, and I've done that before, put pure water, I'm like, oh, let's just do some electrolysis. I put pure water in there and nothing happens. Because the electricity can't flow through it and the reaction can't happen.
Wait, can you say that again? Why can?
So it's electrolyte. It just lets the electric current conduct through. So the electrons on one side again oxidation. So the electrons are flowing through the solution.
Oh, because-
water and there's like a light bulb.
Oh yeah, because water is not a conductor.
Exactly. Exactly.
So,
That's
so
it.
if you put like tap water that has ions in it,